Welcome back to my channel, everyone. Sri Tips here, and I've ordered some computer scrap. It's in this box. Take a look and see what we got in here. Oops. We got 3 boxes of these, and the seller says they're 17 pounds here. So what we're going to do is measure this now and see what the weight is on this stuff. Let's just add the scrap. Let me see, how do we change this to pounds? That's 5 pounds and 7 ounces. There was a few left in the bottom of that box, so I added those in. We got 5 pounds, 8 ounces now. Let's go ahead and get the rest of this in there. These are some nice close trimmed fingers. Should be some good yield on the gold that we're going to try to recover off of here. This one's 11 pounds, 10 ounces. So now what we'll do is we'll take one of these empty boxes. This thing's full. We're going to tear the weight to 0. And then we'll measure the box. Tear that to 0. And then we'll take our next box, the same exact kind of box as this was, and weigh the scrap here with the box teared out. We've got 5 pounds, 6 ounces. Okay, the advertised weight was 17 pounds. We've got 16 pounds, 16 ounces. That's 17 pounds. So it's exactly the advertised weight that the seller listed on the listing. Okay, what we're going to do, I think, is break this up into some smaller batches. And let's see if we can measure out 2 pounds. All right, there's 2 pounds. That's close enough. We'll work with this much material. We've got 2 pounds of trimmed circuit card fingers in here. I'm going to add some distilled water. Cover them with distilled water. So that's about 2,500 milliliters up to the 2,500 milliliter level. And now what we'll do is I've got some nitric acid. I want to measure out about 200 milliliters of nitric acid. I'm going to dump that right on in. And what this will do is the gold foils on these trimmed circuit card fingers is the valuable material that has the value in it, and they're held to those pieces of fiberboard by base metals, copper, zinc, maybe some nickel. And what we're going to do is use that dilute nitric acid now to loosen the foils from the fiberboard by dissolving that base metal underneath those foils, and release the foils so that we can recover them. We'll put this up on some heat now and let this cook for a while. This reaction's been going now for a couple hours, I guess. And so what we're going to do is look inside here. You can see the foils are starting to come loose from those pieces of fiberboard. Let's get in here and see exactly what we got going on a little bit. Try to give this a stir. Oh yeah, look at those foils are releasing off there nicely for us with that dilute nitric acid. I'll give this a stir if I can a little bit. Yeah, the gold foils are coming off of those pieces of fiberboard. That's what we want to see. Still got a ways to go though, so we'll put this back up on the heat and let this continue to react. I think what we'll do is add a little bit more nitric acid, just a little bit more to see if we can get the base metals to go into solution. That's about 100 milliliters of nitric acid. Add that right on in. And that should loosen them foils up for us nicely, so we can complete the recovery. I just stirred this up and the fume production has ceased in there. So I'm gonna add a little bit more water. That's about 150 milliliters of water, maybe a little less. I'm adding some nitric acid now. And then we'll pour this right on in, carefully. This has been on here cooking now for about 4 hours, I guess. And it looks like we've got quite a bit of the foils off. Not all of them. I'd say probably, judging by what I'm seeing here, close to 80% maybe. Still some stubborn foils that are sticking to some of the fiberboard. Been adding small doses of nitric acid to this. And I've got about 400 milliliters of nitric in there so far. What we'll do, I guess, is just keep doing that until I'm certain that all of the foils have been released. Small shot of nitric acid here. And we'll just keep doing this until all those foils come off of there. We're pretty close. This has taken about 6 hours, and I'm fairly certain that we've got all of the gold foils to release from those fiberboard. So now what we're going to do is just turn the heat off, let this cool down, and proceed to the next step. allowed this solution to cool completely. And I think I added some distilled water to dilute it. That's what we look like down in here now. These are our gold foils. The valuable gold foils have been separated from the fiberboard, and we've got all the base metals in solution now, so we can separate the junk metals, the copper, the nickel, and the other metals that were adhering the gold foils to the fiberboard. We can separate those now and claim the valuable gold foils. Okay, the goal here again is to get all these junk metals that are in solution separated from our valuable gold in here so that we can process the solids without the junk metals in there with them. That nitric acid will dissolve the base metals, but it won't dissolve the gold. We'll stand this test here to verify that we don't have any gold in solution. And you can see by that test, no gold was dissolved while we were dissolving the base metals from those fingers. Here you can see in the bottom of the beaker that most of our gold foils have settled to the bottom, and that's the material that we want to process from this computer scrap. One more time, we're separating the base metals that are in solution here from the nitric acid treatment from the valuable gold foils so we can refine the gold foils. And what I'll do with this solution here, this blue liquid is mostly copper in solution. I'll add that directly to my waste treatment bucket that's full of iron, and the copper will come out of solution on that iron. Now we're going to rinse this off with a little distilled water. Try to get as much of that blue liquid off there as we can. The blue liquid will be mostly copper. Here's our beautiful, highly valuable gold from these trim fingers. And this gold is not pure gold. It must be refined. I found that it's about 50% pure gold, or 12K gold. But now that we've got all the junk metals off of there, what we can do is refine those foils in aqua regia and get the pure gold. Now we're going to start the refining process. I'm adding some hydrochloric acid. I'm measuring out about, maybe 500 milliliters of hydrochloric acid. I'll go ahead and dump that right on in. Might be a reaction immediately because there might be some residual nitric acid left in here. I've got some nitric acid here in this bottle. I'm going to measure out about, shouldn't need much. That's about 25 milliliters. I'm going to add this right on in. should see an immediate reaction here. If those foils are real thin and the acid, the aqua regia, is formed by adding this nitric acid, should start to put those foils in solution almost immediately. This has been sitting in the aqua regia now for about 20 minutes, I guess. And what we'll do is bring it down here off the heat and let it cool down for a few minutes. Let's get in here and get a stannous test on this solution. See if we've got any gold in this solution. There you can tell by that dark stain, we've got some gold in solution. Now what we'll do is get set up to do a filtering on this solution that we've collected. Just wanted to show you right here is the filter from that blue liquid that we filtered off. It's got a few crumbs of gold in it, not enough to make a big difference in our yield. So we'll just add that paper to the paper storage and process it and recover it when we do a filter paper recovery and refining video, which should be coming up here soon enough. I get enough yard debris to make a nice hot fire. I've done these fingers in the past, and the usual expected yield from these was about 1.5 grams per pound of material. I'm going to filter out our solution here and gather up our valuable liquid. Do another quick stannous test. I know there's gold in here, but I just want to be able to gauge a little bit on how much we might expect. That's a pretty decent test there. Here's a look at the fingers that have all the gold foils removed. They're pretty much bare. If you look down here, there's still a little bit of liquid in this beaker. I'll probably pour that off into the funnel here, but I just want to show you stannous test. It's barely visible. Just a touch of gold in there, not enough to make a big fuss about. I'll rinse it one more time and add it to this our flask here, and try to recover the remaining liquid that's in there. That's going to be about it for our recovery. I'm using hydrochloric acid here to do this rinse. this filter. This is going to have our gold in it, the solution down here. And inside the beaker, I've still got a little bit of solution. But if you look, it's not enough to try to go in there and recover it. I mean, in refining, every little bit counts. But in this case, you encounter a diminishing return situation where it's going to take more time and effort and expense than it's worth to try to get the rest of the gold that might still be in there. What I may do is just soak this a little bit in some hydrochloric acid and then dump the waste, the solution, into my stock pot. Here's what's left in our filter. So what we'll do now is take this funnel off of here. We'll transfer our solution into a clean beaker. Do this one more time, one more standards test. It's important to verify that you've got some gold in solution before you go to try to precipitate the gold. There you can see by that stain, we've definitely got gold in solution. Not very much. I'm only expecting about 3 grams of pure gold from this amount of those fingers. We're going to add some stump out, which is sodium metabisulfite. We're going to precipitate out the pure gold out of this solution. See those fumes forming on top of the solution? That means we've got a whole bunch of excess nitric in there. What's happening is, as soon as the gold precipitates out, due to that excess nitric, it immediately redissolves and forms those fumes. I'm adding a couple of ice cubes to keep the solution cool as we do the precipitation. That excess nitric in there is going to have a tendency to want to heat the solution up and aggravate the situation. Here we go. I'm going to add another spoon of stump out and see if we can get this gold to come out of solution and stay out of solution. That settled out very quickly, less than 15 minutes. There's our gold down on the bottom. And what we'll do is we'll pour this waste solution off into this temporary waste beaker, and then I'll add this directly into my stock pot. Alright, here is our pure gold powder down in the bottom of this beaker. Let me give this a little bit of a rinse with some hydrochloric acid. Let that settle out for a second. I want to try to get the highest yield that we possibly can from this small amount of gold that we're processing here. I've rinsed this a couple times with some hydrochloric acid and a couple times with some water, distilled water. This is looking pretty good. So I think what we're going to do is I'm going to add some hydrochloric acid. A little bit of sulfuric acid just in case we got any lead in there. Now let's pull up our heating pad up here. I've got this all set up. I'm going to apply a little bit of heat here. I'm going to put it on time lapse, add about 3 milliliters of nitric acid. We're going to redissolve this gold a second time. Here we go. I've evaporated this down, and I can tell by the lack of fume production that we've got all the excess nitric driven off out of there. So what we'll do is we'll pull this down off this heat now and let this cool off. You can see the funnel, the filter is clean as a whistle. Let's get this into a beaker now. Stomp out one spoon. Should just about do it for this. Should only about 3 grams of pure gold. Let's go right indicated we still got some gold in solution. So let's go ahead and add a little bit more SMB. See if we can get the rest of it to come out of solution. Our gold looks superb. Nice caramel color. I'm going to pour the waste off into this temporary waste container. Pour off this rinse now. That's our pure gold. I've got a dish here with the weight on it. I'm going to transfer our gold into this little dish. Looks like we've got it dried off. So now what we'll do is get it down on out of our drying dish. We're going to get a weight on this. Looks like we've got 44.5. 44.5 minus 40.8. So we got almost 4 grams. Divide that by 2. That's 1.85 grams of pure gold per pound of those trimmed fingers. Now we're going to transfer the gold into this little melt dish. We're going to take it over to the melt table and melt us up a little button of gold. Here's our little pure gold bead button. It's got a bunch of borax flux on it. So what we're going to do is we're going to put it in this beaker, add a little distilled water, and then we'll put a little sulfuric acid in here, and put it up on some heat, and that'll get that flux off of there for us. Had this on the heat now for about 10 minutes. Take this in, get our little gold button out of here. That thing looks fantastic. I've got all the acid rinsed off of there now. Here's our little gold button. Man, that thing looks fantastic. Nice, clean, pure gold button. Let's take it over here. See if we can get a weight on this thing. .7 grams of pure gold. Here's our little gold bead. I've got SREE and then 3 9s. And this thing weighs in at, here's our tub of computer scrap. We'll be doing some more experiments with this. Probably do a video on putting this straight directly into Aqua Regia and see how that works out for a future video. And so what we'll do is we'll offer this one for sale on our eBay site. 3.7 grams of pure gold from our computer scrap. All right, that'll conclude the video. Thank you for watching.